more of a definition today. So here it is. There is the definition of explicit and implicit differentiation. Explicit differentiation is what we have been doing in chapter 3 up until today or yesterday. Explicit differentiation is when you have a variable that is what? Solved for. So you need to write that down. That's explicit differentiation. Implicit differentiation is when the variable is not solved for. Now, the first thing that pops in your mind is, well, why don't we just solve for it? Well, there's some problems you can't solve for y unless you go into all kind of long division and all this other stuff. Okay? Good gracious, Miss Martinez, you making me dizzy. Miss Martinez, I'm mad at you anyway. You almost got kicked out of the class.
Oh.
I was going through, I go through and I check the rosters on Teams and the roster and My Labs Math, and I could not find you on My Labs Math.
Yeah.
You know why I could not find you on My Labs Math?
Because I haven't been doing it. Yeah, we've been.
Well, you said that. That wasn't what I was going to, but thank you for giving us the information that you're lazy as hell. But no, I'm just kidding. Your last name was not, you did not put Martinez on your last name, or it didn't take it, and it had Leon. And I was looking for Martinez. And I spent all afternoon yesterday trying to find, and I was fixing to write you an email and say, why aren't you on My Labs Plus? And then I figured it out. So
yeah, I go by Leon instead of Martinez.
You're in the doghouse, so you're going to fail. All right, so I'm glad I finally found you. All right, so these are examples of, now I'll show you an example right here that is a homework question. And I'm gonna give it to you for right here. And it is, well, no, I'm not gonna show it to you yet. I don't know why all of a sudden my ceiling fan is making all these papers fly around. I haven't been doing that all semester, but today. It's a conspiracy. Okay, so that's how you know when to use implicit differentiation. And I think that's supposed to be IM. I don't think it's supposed to be IN. And I'm right. I knew that didn't look right. Implicit. All right. So here is an example. Come in, I'm getting mad. I'm going to give you an example of implicit differentiation. And my black pen, there it is. X squared plus y squared is equal to 12. Okay, so what do you do first with implicit differentiation? One, you go through and take the derivative of everything. And then I'm going to get my red pen out. And you know what that red pen means? Anything with y gets a y prime beside it. And that pen is shot. Okay, so anything with y gets a y prime beside it. Now there is no y. Well, technically, it's the chain rule. Okay, and I'm not going to go through and show you why. It's basically because of what's inside. You take the derivative of what you're taking the derivative of and the derivative of what's inside, and that's why you have to put a y prime beside it. So if I go through and take the derivative of everything in here, go through and take the derivative of, let me take a pink. Why do I say everything right here? Why do I highlight everything? What do students do? They'll take the derivative of that x and that y, and then they'll stop. What does everything mean?
Every number and variable.
Every number and variable. So you got to take the derivative of that 12 too. So let's go through and do that. Now, when I go through and do it, I'm also going to put a y prime in orange beside that y term. So 2x plus 2y, y prime, is equal to 0. And after you go through and you do that, just like when you were doing the inverse, what's number 3? Solve for what? Solve for y prime. Get y prime by itself. So go ahead and do that. Just a simple 2 or 3-step algebra process. Two y times y prime is equal to negative 2x. Divide by 2y. Divide by 2y. And y prime is equal to negative x over y. Now, does everybody see this equation of a circle? Everybody see that? I want to highlight that in green. Why am I highlighting that in green? Because you're going to see that on a standardized test. I don't care if you're doing a GRE or a clinical exam for nursing or an entry exam just to work at Michelin. If they ask you to use implicit differentiation, usually they give you the equation of a circle, which is x squared plus y squared is equal to some number. Does everybody understand what I just said? Yes, no, maybe?
Yes.
Usually on a standardized test, when they ask for implicit differentiation, they're usually going to give you the equation for a circle. And it's going to end up something like this. And on my test, you will see that again. All right, so let's do a nerd. Let's find one that will discourage you a little bit. Let's find one that you probably will skip because you don't want to do it. I went through, excuse me, you know where I got these from? Anybody want to take a guess where I got these questions from? Your test. X squared plus y cubed minus 4x is equal to 8. All right, find y prime. And just so you won't feel alone, and just in case you're too lazy to write down notes, there you go. I tell you, I do so much for y'all. It's just amazing what I do. I want to ask you a question. How many people in here, and you don't have to tell me, I mean, if you get too embarrassed, that's okay. But if you're not embarrassed, because there's a lot of people who've taken calculus over, how many people in here have had Math 140 in another school or another time? Anybody?
You mean 141 or
140.
Yeah, I
This
have.
class. Anybody? What'd you say, Mr. Piella?
I did, yeah.
You remember implicit differentiation?
I do. I didn't get it the first time around.
Yeah. I was going to ask you if it was very confusing the way they explained it.
It was, yeah. It was very confusing.
I guarantee you, $1 to a donut hole, they did not do this, did they?
They did not, no.
Yeah. You know why? Because they get all that stuff that's in the book and they just put it on the overhead and they give it to you and say, here it is.
Yeah, they don't teach it.
That's how you do implicit differentiation. You're welcome. All of you, you're welcome.
Thank you.
Because you ain't going to say thank you, but go ahead. You know, you're welcome. Don't worry. You're going to take Calc 2 and Calc 3. You're going to find out. You're going to be like, oh, wish I had Hubert again. All right, here we go. 2x plus 3y, y prime, minus 4 is equal to 0. So I just went through and I took the derivative of everything and I put y prime beside the one that I took the derivative of y with.
I think it's supposed to be 3y squared.
Of course it is. Thank you. I suck. There we go. Who was that? Who was that?
Gonzalez.
Thank you, Miss Gonzalez. Oh, we got a finger. We got a thumb. All right.
Thumbs up.
You are just going out of your way, Miss Gonzalez. You're just being the social butterfly. All right. So now we're going to take this 2x over and this 4 over, and we're going to get 3y squared times y prime is equal to negative 2x plus 4. And now we're going to solve for y prime. And people, that's not hard. And I'm not going to worry about you simplify. You simplify this however you need to. This one you can't simplify. But that's it. Now, tell me, Mr. Piella, how hard is that?
Not hard.
How many of you, anybody else want to volunteer if they've had Math 140 before? And tell me the comparison between implicit differentiation in that class and in this one. Anybody?
Yeah, it was not the same.
Not the same. This is called pragmatic. This is called layman's terms. It's called real world. Okay? Let's do a nerd. Let's see if I can find another one that I pulled from the test. Okay, now this one, time for a nested problem. Time for a nested problem. Time to break out the new pens. Y squared plus 5x squared y cubed plus x to the fourth is equal to 9. So y'all might as well just what? Might as well just quit. Why? Too much work. Somebody tell me where the nested is. Where is the property inside the property? Where is it?
5x or y cubed.
What are you going to have to do there?
Rewrite it or break it apart.
Well, what kind of rule are you going to use there?
Chain.
Not chain, but what?
Product rule.
Okay, because you know it's not the quotient rule because it don't have a fraction bar. So product rule. So I'm going to put yellow brackets right here. First times the derivative of the second plus the second times the derivative of the first. And we're going to do that in just a second. 2y times y prime plus 4x to the third equals 0. All right, I'm going to let y'all do this one. I'm going to let y'all do the product rule, and then we'll keep on going. Okay, yellow brackets. 5x squared. And what is the derivative of y to the third?
3y squared.
Y prime. Plus y to the third times 10x. Are we done with calculus? Yes. So I guess y'all need to start on your algebra now. And that's a +1 right here. So those yellow brackets, they can just go away because that's a +1. So you don't really need the brackets. So you got 4 terms, and 2 of them need to go on the right side so you can factor something out. So I'm going to let y'all work with it. So I'm going to go to black now, if y'all don't mind, except for the y primes. So 2y times y prime plus 5x squared times 3y squared times y prime plus 10xy cubed plus 4x to the third is equal to 0. So the reason I did this line right here is so you can see how many terms do we have a y prime? How many terms do you see a y prime?
2 terms.
Thank you, Mr. Piella. Thank you. So the other 2 terms can go where? They can go over here. So I'm going to 2y times y prime plus 5x squared times 3y squared times y prime is equal to negative 10xy cubed minus 4x cubed. And now what are you going to do here? That means I want somebody to communicate.
Divide by y prime.
Not divide by y prime, but you do divide, but what is it called? Starts with an F.
Factor?
Factor out a y prime. So y prime goes out here, and that gives you 2y plus 5x squared times y 3y squared. And you can combine that and make 15x squared y squared if you want to. I really don't care about that. Equals negative 10xy cubed minus 4x cubed. And now divide by all that trash. And divide by all that trash. And that goes out. And you're left with y prime is equal to negative 10xy cubed minus 4x cubed over 2y plus 5x squared, or 15x squared y squared. That type question right there, you'll see on a Calc 2 review section. Like next semester, when you're in Calc 2 and you got a review section, that question will be on there, one like it. What do you notice about the way I did this problem? Can somebody say, what can you tell me the way I did this problem? That means I want somebody to communicate besides Mr. Piella.
You broke it up into different parts.
Thank you, Mr. Williams. I did everything step by what?
It's Williams Madison.
I did it step by what? Sorry, Mr. Williams Madison. Step by step. And what do y'all notice about that? It's very easy to what? Follow. Oh, but there's some of y'all out there, y'all don't need step by step because y'all invented implicit differentiation. And y'all try to do it in 2 lines. It doesn't work that way, people. Okay? You may think you know everything, but I'm going to tell you right now, implicit differentiation takes practice. And you need to practice it. I got one right here that I didn't even, I haven't even done it. Where is it? Hold on a second. Well, I thought I had one. We started this one the other day, I think, or one like it. We started one and they wanted y prime, I think. All right, here's one where they want y double prime. So x squared plus y squared is equal to 25. And the directions say find y double prime, or if you want to f double prime of x. However you want to write it. Sometimes they say d2y over dx or something like that. In other words, find the second derivative. Now I'm going to let y'all work with that and see what you come up with. Find the second derivative. And don't be surprised if you don't know what to do on the second part, okay? Because a lot of people don't. So go ahead and find the first derivative at least. That won't be too much trouble. And if you can't do it, then we'll just write you up as a failure. Oh, did y'all see the latest in the news? They're saying that the coronavirus was created in a China corona lab. Duh. Oh, me. And some of y'all have no idea what I'm talking about.
I thought we already knew that.
Oh no, it wasn't created in a lab. It come from a bat. You didn't know that? That's the Kool-Aid they were trying to give everybody on the news. And it was created in a dadgum lab by China. But we're not going there. That's why people were calling it the China virus, because it was created by China. 2x plus 2y times y prime is equal to 0. Oh, me. And 2y times y prime is equal to negative 2x. Divide by 2y, divide by 2y. Y prime is equal to negative x over y. Everybody with me? Now I want you to take the derivative of negative x over y. Now you can use the product rule or you can use the quotient rule. I'm going to use the quotient rule. And the derivative of y prime is 1. So we're not worried too much about that, because if you want to just change that to double, you can. So, well, not right here. That's y prime. Now we're going to take the derivative of both sides, and that's going to give us y double prime is equal to denominator times numerator prime minus the numerator times the denominator prime all over the denominator squared. And that's going to give you y double prime equals, what's the derivative of negative x?
-1.
Times y. And then that negative makes that a positive. And that's positive, and we'll make this 1 times y. So that's going to be, excuse me, positive x times 1 times y prime over y squared. So let's simplify it a little bit more. Y double prime is equal to negative y plus x y prime over y squared. Anybody have any idea what we can do now? Anybody? Well, what is y prime?
You plug negative x over y in.
So what do you think we're going to do with that negative x over y?
Plug it in.
Plug it in. Thank you. So I'm going to take my handy dandy y double prime is equal to negative y plus x parentheses negative x over y, all that divided by y squared. Now you're going to do your algebra and you're going to simplify a complex rational expression. So you've got several more steps. So don't quit just because you plug that in. You've got to clean this up. So go ahead and clean it up. I'm going to copy this on the next page. Y double prime is equal to negative y plus x over y squared and negative x over y. Well, you can clean it up now. Watch what I do when I clean it up. Watch what I do. negative y minus x squared over y squared. What did I do? I made everything into a fraction so you could see that the common denominator is what? Y, Hubert. That's right, class. So now I'm going to multiply both the top and the bottom by y over 1. So go ahead and do that. I'm just going to put a y here, a y here, and a y here. And that's going to give me y prime, double prime, is equal to negative y squared minus x squared over y to the third. And that is your second derivative. Now, what are we talking about here? We're talking about 80%, this whole problem, 80% algebra, 20% calc. Where's the calc? Well, in the first part, right here, you did this right here and solved for y. You got that. And then the second part, right in here, you got that. And then you did the algebra. And you did algebra in between also. So now when you go to your homework, you can do the problems. There was one other problem I had, and I can't find it. I want to find it because it's the quotient rule. And it was on your test. Give me a second. Well, it's not there. It's not there. There it is. No, that's not it. Let me go to your homework, see if it's in your homework. I wanted a quotient rule in, because we did the product rule. So let's go to, what section is this? Implicit is 3.8. I think that's it right there. I want to make sure. Yeah, that was it. All right, write that one down. So 3y is equal to x plus 10 over y minus 10. And I'm going to let y'all have 2 minutes and let you work that problem and see what you get. Miss Qualls is concentrating and Mr. Adamson is sleeping. Mr. Adamson is like,
Not quite.
well, you just look like it the way you were sitting.
Yeah.
That's okay. I know how it can be, especially in a calculus class. I'm not fussing.
One thing I can't do is math uncomfortably.
Yeah. All right, I'm gonna give y'all another minute and a half. All right. I gave y'all a little bit extra. So the derivative of 3y is what? 3y prime. Is equal to, oh God, we got to do the quotient rule, so we might as well just quit. So y minus 10, denominator, times numerator prime minus the numerator times the denominator prime over denominator squared. Okay, so 3 times y prime is equal to y minus 10. And somebody tell me the derivative of x plus 10. Thank you. Minus, I just love it when the classroom communicates. It's just great. X plus 10. And what is the derivative of y minus 10?
1.
1 what? Y prime over the denominator squared. Okay, now you're done with the calculus. So we got to 3 y prime is equal to that 1 distributed as y minus 10 minus x y prime minus x y prime minus 10 y prime. Y'all check me on that. Over y minus 10 quantity squared. Now, I'm not going to be able to do anything until I get rid of this y minus 10. So I'm going to multiply both sides by y minus 10 quantity squared. Everybody with me? Good gracious.
Yep.
This is a mess. So I've got to multiply by y minus 10 squared multiply by y minus 10 squared. And that's going to give me 3y prime times y minus 10 squared equals y minus 10 minus x y squared, or y prime, minus 10 y prime. Now we got to do shortcut number 2, and that's going to be y squared minus 20y plus 100, and then distribute that 3y prime, and then we can get our y primes together. So I'm going to go to the next page and rewrite what we just did. No, I'm not. I'm just going to fold it because I'm not going to. There we go. All right. So this right here is going to be 3 times y prime. And then shortcut number 2 will give us y squared minus 20y plus 100 is equal to y minus 10 minus x minus 10 Then we've got a y prime there and a y prime there. And this is going to be 3y squared y prime minus 20y y prime plus 300 y prime equal to y minus 10 minus x minus 10 y
Wouldn't it
prime.
be negative 60y prime?
Where?
In the beginning, when you distribute, wouldn't it be negative 60y instead of negative 20y?
Thank you. You're right. Thank you. 3 times 20. Thank you. 3 times good. Thank you. You're supposed to wait till the very end of the problem. And that's when you're supposed to tell me that I made a mistake. That's what most students do. And then half the class goes, oh yeah, I thought that, but I didn't say anything. So thank you, whoever said that. Who was that? Was that Miss Gonzalez?
No, that was me, Chloe.
Thank you, Miss Lang.
You're welcome.
I hope you don't get chastised by these weaned on a pickle students for communicating. All right, so we still got a mess. I'm going to bring this over and this over because everything else has got y prime in it. And I'm praying this seems awfully long for a question. I hope we haven't made a mistake. Minus x minus 10 equals y minus 10. And this is y prime here, y prime here, y prime here, y prime here, and y prime here. And of course the y prime comes out. That leaves you with 3y squared minus 60y plus 300 minus x minus 10 equals y minus 10. I'm looking to see if anything, that minus 10 and that 300 can combine, and we get y prime times 3y squared minus 60y minus x, what, 290? Y minus 10, and divide by 3y squared minus 60y minus x plus 290, and divide by 3y squared minus 60y minus x plus 290, and pray that that is the answer. But I can tell you that's awfully big and complicated for it to be one of these answers, but I don't know. Let's see what happens.
Would bringing the xy prime and 10y prime over not be adding it?
I didn't bring the y right here. It was already over here. The y and the minus, I just left it. It just stayed right here.
No,
Is that
but
what you're talking about?
no, right beside it, the xy prime and then 10y prime.
Did I not bring? Shh. Okay. Thank you. Been better if you said it up there instead of down here.
Well, I was writing my own problem down and just looked
I
up.
know. All right, so that would be a plus x. Y'all check me. And a plus 10. And that would be 310. And 310. Would that be the difference? And I'm not even going to try to go any further because I'm tired of fooling with it. So let's go and look at the problem. That's awfully complicated. I don't know if that's the right answer or not, because that is awful tedious. Yeah, see, I didn't think it was. And you might be able 1 over 6y minus 30. You might be able, I see a 6y right here. You could, see, you could factor that bottom. I'd have to go on and do this, but I'll play with it later. But you may be able to factor that bottom. I'm looking, I don't see anything. You could factor out a 3y here. And that would leave you with y minus 20. But there's nothing over here. I don't really see anything. So that means either I've got a mistake somewhere or something. I knew when we were doing all these, when I saw all these y primes, I knew something wasn't right. We'll have to work on that one tomorrow. All right. Let's see how much time we got. We got about 4 minutes. Oh, not 4 minutes. We got about 10 minutes. Got some problems that we could go over. Homework problems. Let's go over some of these. I'll have to do that one again tomorrow and we'll figure it out. 3.9, 7920. 3.9, 7920. And this is f of x is equal to 7 to the x, or 7x raised to the natural log of 7x. Now, when you see a problem like this, besides quitting, what should you do? Well, when you see one like this, I'm going to put it in parentheses over to the side. Take the natural log of both sides. Now, a lot of you saying, well, here we got to take the derivative. I know, but you're using logarithms to take the derivative. And change that to a y. So y is equal to 7x raised to the natural log of 7x. And I'm going to take the natural log of both sides. And I wasn't supposed to paint that red. Okay, now I want you to use the natural log rules to expand this. You got 2 or 3 steps over here that you can expand this before we start taking the derivative. So go ahead and use your your logarithmic rules to expand this. You got a power right here. You got multiplication right there. So there's 2 properties that you need to do to expand this. Can anybody, well, I've already told you. The power rule and the product rule. And I'll get you started because y'all end in 1 minute and some of y'all start convulsing. So natural log of y equals natural log of 7 plus the natural log of x to the natural log of 7x. Oops, I'm sorry. X to the natural log of 7x. And then bring that out using the power rule. Bring this out using the power rule. And that's going to give you, and this is where you should start, natural log. Oh, crap. I done mixed up my pens. Hold on a second. Natural log of y equals the natural log of 7 plus natural log, well, that would be a different color. Oh, the things I do for y'all. Natural log of 7x times the natural log of x. And now you can take the derivative. And what is the derivative of the natural log of 7? Somebody tell me right quick. Come on, right quick. Don't even have to think about it. What is the natural log of what is the derivative of that?
0.
Good job. Why is it 0? Tell me why it's 0.
Because natural log is just like a number.
Because it's a number. The natural log of 7 is a number, like 6. So the natural log of any number is 0. So what is the net? This is 1 over y, and this is where I'm going to stop. 1 over y times y prime is equal to 0, and then you got the product rule right here. First times the derivative of the second plus the second times the derivative of the first. All right? Finish it for homework. All right, let me look at the roll right quick. I only got to check a couple of names, and I haven't logged in, and hopefully that logged me out. Good. All right, so let me turn off the present and turn off the recording.